Cortana, reroute energy from the mortgage to purchase a crate of Funko Pops.
But Master Chief, that is not a microtransaction. That's a macro transaction.
So hi guys, I'm here with Fries. I feel like I should have a nickname too.
You got one?
Yeah, I've got one. My nickname is Mangoes.
Mangoes.
So we're going to talk about OpenGL and what it is. OpenGL from zero to hero.
Because I have zero experience with OpenGL. Probably going to ask a lot of stupid questions.
But that's okay, because you're coming at it from a fresh perspective. I think there's a chance you've probably already programmed graphics cards. Have you done CUDA at all?
Oh, CUDA, yes, that actually I did. For AI courses.
So there are two major areas which use graphics cards, AI and graphics. In the case of AI, it's because you need to multiply matrices really quickly. And in the case of graphics, it's because you need to push data to the screen really quickly.
Do things quickly.
I've been tutoring graphics for like a number of years, and people are often surprised to find out that there's actually nothing special about a graphics card. Like, they're pretty cool, but there's nothing special
They also
about
got more expensive, I heard, after people discovered that you can do things quickly with them, and then AI, and then...
Somebody purchased like a new NVIDIA card, and they were tweeting about this. They were saying they had a rendering engine which was like super efficient. And then the graphics card sort of decided that, oh, maybe they're doing crypto mining because it's being so efficient, so it throttled itself.
The graphic card forbids you to do crypto mining or something?
Well, this is getting a little bit into conspiracy theories, but you know how there was like a time when graphics cards were just graphics cards, and then Bitcoin became really big, and then all of the scalpers were buying up like the NVIDIA cards, and the prices just shot up. So these are all examples of like programming that you do that deals with the graphics card, but no one wants to deal with a graphics card. It's a nuisance. Ain't nobody got time for that. So what OpenGL does is it sort of gives you an interface to talk to the graphics card. So when you're making a game, there's sort of two things. There's data and algorithms.
Yes.
Data structures and algorithms.
Ah, yes.
So data, you've got like resources. So you've got like, if you have a texture and you want your texture to appear in the game, you load from file and you upload all those pixels. And the graphics card sort of throws that somewhere in the VRAM, in the GPU, and then you can use that later on to display things. You can also have buffers. So a buffer is literally just, it's just an allocation. You can literally put whatever you want in there. A really common usage is like positions. So if you've got a bunch of triangles that you want to display, you can record the X, Y, Z coordinates of all the positions. That's sitting there on the GPU, that's ready to go, just an array. You say, use it, draw it.
Done.
Another case is you can have a buffer, so again, just a really big allocation of whatever, and you can fill it with matrices to represent transformations of objects. So then you can tell the graphics card, okay, use these transformation matrices, draw this object, and it will look in there, pick the transformation matrices.
Buffer.
Exactly. And it'll draw like the same object at a whole bunch of different positions. But basically that's OpenGL. So OpenGL is literally as simple or as complicated as you want it to be. So I figured we'd talk about some OpenGL myths.
Is OpenGL dead?
No.
I figured that if we're talking about it right now, it shouldn't be dead. Otherwise, why are we talking about it?
OpenGL is not the only API. For some reason, around 2015 to 2016, a lot of these different graphics libraries became super complicated. They became a lot more low level. People were saying, hey, why is it that I'm getting like the latest NVIDIA card and it's got like gigabytes and gigabytes of RAM, but it's still like super slow? Graphics programmers were like, okay, well, we've got OpenGL, and it gives you this simple way of working with the graphics card. It's doing all this stuff under the hood. How about we just open that up and give you everything? And that's what they call Vulkan.
Is that a pun intended? Open.
Yeah, yeah, that's right. They opened OpenGL. But Vulkan is a nightmare. Later on, we're going to do a triangle.
Yeah.
Super simple. In Vulkan, it's about 900 lines of C++ code
900 lines.
to draw a triangle.
Equilateral triangle or just
Just one triangle.
any triangle
Yep,
takes 900 lines.
about 900 lines. Well,
Is it colored in?
yeah, it's colored. You can do that, at
At least better than not colored.
But the colors are hard-coded.
That sounds
It's a
terrible.
nightmare. A lot of people said, well, if I want to get maximum performance, I've got to use the latest thing. Vulkan, OpenGL, get rid of it. OpenGL is still actively being developed by the community. Anytime I think I finally found something that Vulkan does that OpenGL can't do, like the next month, an extension comes out, making that available in OpenGL. And another point that I want to make, my big thing is that OpenGL is always going to be around as an educational tool.
Fundamentals of interactive computer graphics.
Yeah, this is by IBM. It always comes down to matrix algebra. People come in, they're like, OpenGL is old tech, and then they can't do matrices. So here they have a 3D object, and they can get different views of it.
It's super old.
Yeah,
Oh, it's tracking.
yeah, so by picking out on the object, you can sort of pick out. So the point that I'm getting at, this is 1963. What were you doing in 1963?
I don't think I was even there.
I was in a past life in 1963.
Probably in my past life as well.
So all this lost knowledge of maths, like it's relevant back then, it's relevant now. If someone learns graphics, even if they learn a modern API, they still need to go learn vectors. They still need to learn like model view controller patterns.
Matrices. Linear algebra.
Linear algebra in both AI and graphics.
Yeah, they're
That's
very useful. Is OpenGL 3D only?
No, OpenGL's not 3D only. So one thing that's like a lot of people find surprising is that when you work with the graphics card, there's no point at which, oh, now it's 3D.
There were never 3D.
It's never 3D.
I think we're simulating 3D more like.
And you can even do pretty cool stuff not in 3D.
This may be a bit off topic. Now that VR's coming out, will OpenGL be able to, will they be able to render graphics in the VR games?
As we get into like VR and AR and all of that, things like performance actually matter a lot more. In a video game, you have about 16 and a bit, 16 and 2/3 milliseconds to render a frame. But it turns out that if you do that in VR, people get motion sick. So in VR, you need like 10 times less, like about a millisecond, to keep people from getting motion sick. So graphics programming is super, super important.
In VR, especially in VR, more than normal gaming.
So one day I got a bit bored, and so I stress tested a Pygame. And what I did is I drew a whole bunch of sprites on the screen, and I'm like, how many sprites can we handle before?
With Pygame?
Yeah, before things break. So here we've got 2,048 sprites. The sprites, I just downloaded a set of random images. So at random positions, random sprites, 2,048. How many frames per second do you reckon Pygame could do?
256.
256. Okay. We have
Okay, that is, I'm
about
way off.
28, 27,
I probably
28.
should follow my intuition and go for a low number.
Well, this annoyed me as well, because I looked it up. I'm like, well, what's happening here? Like, this should not be this slow. I've made like real-time ray tracers which go way faster and do a lot more work. I'm like, so if I just made a basic OpenGL program that does the same thing, it should go way faster.
Does it?
Does it?
What? 450. That's not 3D.
That's 2D. The only thing it's doing is saying, draw this thing fast. I mean, it's doing a lot of other things under the hood.
Is it like redrawing it or like redrawing the entire canvas? Not instead of just.
No, it is dispatching all of these things individually. But because that runs in parallel, you've got like, imagine like one thread drawing each of these pixels.
Pygame, you don't have that parallelism, so.
No, in Pygame you sort of leave it up to Pygame and it does whatever it wants, and for some reason it doesn't do that.
Is OpenGL hard? Should I anticipate myself for being thrown under the bus?
Not hard at all. Not hard at all.
Not hard at all?
No.
But shouldn't it be scary? It's like deep stuff. You are touching the graphics.
There's a mode we can work in called Legacy OpenGL, where the only thing you need to say is like, hey, start drawing, draw a point, draw another point, draw another point, stop drawing. And that's it.
That's it?
And that's all. That's it. And that's all you need to do to get a triangle on the screen.
Is it going to do the same thing we're doing here at the end of the video?
Maybe.
I'm scared.
So Legacy OpenGL is the way OpenGL worked from like the 1990s up to like the early 2000s. And it's a mode where you basically say, it's called immediate mode. Immediate mode is where the CPU and the graphics card are like communicating all the time. So the CPU will say like, okay, start drawing. And the graphics card will say, all right, we're drawing. Give me some points. And the CPU goes, okay, here's a point. Here's another point. Here's another point. Okay, stop drawing. And then the GPU goes and does its thing. So it's a very intuitive way for beginners to start working with OpenGL, because it's fun, it's nice. But a lot of people say you can't use Legacy OpenGL, that's old tech. Guess how much I care about that?
A lot?
Zero.
Zero?
I care zero. I just want people to get in and have fun. Side note, Legacy OpenGL is fast.
How fast?
So this is like completely naive. It's currently taking about 50 milliseconds per frame, which would be about 20 frames per second. Pretty slow, right? Mm-hmm. Yeah. What we can do is a neat little trick I like to call aggressive optimization.
Aggressive?
Aggressive. Not passive aggressive optimization. This is aggressive.
Aggressive.
Aggressive
How
aggressive.
would you do a passive aggressive optimization?
ChatGPT.
Oh.
Yeah, so here we are down to like 5 milliseconds per
So
frame.
that's 200.
Yeah, about 200 frames per second. And the really cool thing is I've also got sort of the number of draw operations which are happening. And then depending on our situation, we can actually get that down quite a bit.
You don't have to see that many things when you are closer.
Exactly. If you're just clever about your game world and you're clever about determining what you can see, you can really restrict the amount of operations which happen. So if you can see, this is a top-down view. It's a little hard to see, but that teal cone...
Is the part you're looking at?
Exactly. And you can see that as we're looking around, that is changing. You can see that the grid system also detects like objects.
Obstruction.
Exactly. That in combination with
The aggressive optimization?
aggressive optimization. So when I say aggressive optimization, do you know a number? This package here.
I don't know.
Okay, what this does is you can make functions, you can decorate these functions to be just-in-time compiled. So you're using Python, you're writing Python code, but then on the fly that Python code gets compiled to machine code. And so you get like machine code level performance from Python. So my point is like maybe the rendering operation is a little slow, but if you're really clever about like working out what gets rendered, then it actually doesn't matter.
All right. Mac OS doesn't support OpenGL. Well, that concerns me because I do have a Mac OS. I have a Mac. I've suffered for it.
Yeah. What do they say? Buy once, pay forever? That's what I say when I'm in the library and I can't get my power adapter to fit into the slots.
Oh, yeah. No.
Yeah, so the deal, there's a little bit of truth to that. So the deal is there are OpenGL versions. The most recent version is 4.6. That's where the versions stopped and community extensions were needed to keep things moving forward. Mac, anything beyond 4.1 or really 4.0, something like that, it does not support it.
Unfortunate.
Unfortunately. The good news is that everything around OpenGL 3.3 is pretty useful. So most things you can do, like what's your favorite video game?
Rainward.
You can do that in OpenGL 3.3. You can do that in Mac. I've done skeletal animation in Mac. It works. It works pretty well. There's no issues. There is one thing, which is the tools to debug OpenGL don't work in Mac. They don't have them. I've been in situations where you're trying to debug something on Mac in OpenGL. If it doesn't work, you get a black screen.
Oh,
And that is all you get.
that is the only thing you get when you try to debug.
Yes, yes. There is a function that you can call to say, hey, get the latest status of the API. If you run an OpenGL operation, you remember we talked about validation layers?
Yes, yes.
Yeah, so you don't get that at all in OpenGL.
No validation layer, no
Yeah.
bouncer for
No,
checking?
no bouncer. No, it's a nightmare. What they have is in the club, they have like X days since our last incident. And they just, they tick that off, right? So you run the function and then you say, hey, by the way, what's your status code? And if an error occurred, then there's a status code there. But you need to determine which function set off that status code. Because any function that gets called can set a status code. And there's actually like a stack of status codes. So what you do when you query it is you're just getting the most recent error message. You have no idea which function caused that error. So you got to use print statements.
Just use print statements.
Just use print statements. It's better for debugging. So I'm not kidding. That's seriously how it is.
Oh, don't we all love with prints? But I guess any programming has pain, so
It's
just
character building.
the severity of pain. Do you want to go more painful or normal average programmer pain? All right, the next one we have is Python is slow. Is Python slow? Comparing to other programming languages, I heard pretty often that C is faster when doing competitive programming.
It's a question of how masochistic you are.
I think it's faster to write stuff in Python, so that does make things up. In some cases, I don't have to think about too much of the consequences. Python's pretty flexible.
So let's say that we have 200. Okay, 200 boxes rotating around, each with their own positions and rotations in Python using the full like standard Python code.
Mm-hmm.
How many frames per second do you reckon?
120?
120, okay. It's about 23 frames per second. So
Never gets it right.
this is like naive approach to Python. This is like, I'm gonna do inheritance, I'm gonna do like all the standard
We love
Python.
inheritance.
We love inheritance. Question, what if I take all of that like Python code and represent these objects as entries in a NumPy array?
Can I still keep my answer at 120?
120?
Or maybe
Okay.
double again?
Okay.
240?
240, okay.
It's around 280.
Yeah, so you basically get about a 10x speed up,
That's much closer than my other guesses.
just switching to NumPy arrays.
Just switching to NumPy
Just switching to NumPy arrays. Now, if we did compile this to machine code, what performance do you reckon we get?
Well, last time it's 10 times. So
I think this laptop is the devil, and it has like something which is limiting the frame rate artificially.
800.
800.
Sorry, that was
Okay.
my way of
Yeah.
throwing a coin. If you make decision quicker, you have more time to. Whoa, that was.
750.
Did it start out a little crazy?
Yeah. So what? That's sort of because I'm up. You can see that I'm sort of updating the frame rate every second. So it has a second of like super high performance where it hasn't adjusted to the frame rate yet. Do you want to see how?
Sure. You assign things to the target array. I assume.
Basically, what it's doing is it's saving all the direction vectors for the camera's frame of reference. Oh look, 1,000.
1,000.
Yeah.
1,100, actually. Almost 12. Made it to 12. That's pretty cool. Guess depends on how much effort.
Okay. So simple example, just doing a ray trace scene with a bunch of spheres.
Number of bounds it takes to disappear.
Yep, that's right. And the number of samples which are taken per pixel. So this is not a real-time thing, but we just go through.
This is naive. It's taking a while.
We can see that takes about 32 seconds. So we can take that as a baseline. So in these optimizations, I'm not using NumPy. I'm not using machine code.
Unreadable but faster.
Unreadable but faster. And what I'm doing is I'm making what's called a cache, where I've got a list of floats, and that list of floats holds all the local variables.
It's faster to access.
That's right. Because in Python, when you make a variable, it allocates something dynamically on the heap for everything. which, dynamic memory allocation is really expensive. So what we can do is have this persistent object and pass it in as an argument to every function, and then make sure that the bits that we're reading to and writing to are physically close to each other in the cache. So you have like this list, and then one function writes to this part. The next function reads like this part and writes to this part.
So I don't have to move that much. I don't have to move. I don't have to run a mile to just update a pixel.
Exactly. It just rips through it.
It's got a little slower here, but
Yeah.
much faster than the last time. That took 20 seconds.
20 seconds.
20.3958194255828886 seconds.
Yeah. So if you want to get into it, like there are ways to make code run fast. If you submit this for a university assignment, you will fail style checks. But it works faster.
That is unfortunate, but it is faster. You
True.
wouldn't necessarily fail though. The style check doesn't take that much mark from you.
That's true. That's true. Yeah. You might get respect. You might get some street cred for code like that.
Is OpenGL only for graphics? I don't know anything for OpenGL except the bits you gave me. And that's all about graphics, so it's not.
No, it's not. So it can be used in video encoding as well.
Video encoding?
That's right. So it can be used for image processing. Let's say you have a video. A video is an image sequence. So it's a sequence of frames. Each of those frames is an image, and if you have a whole bunch of like video filters that you want to put those images through, like blur and stuff like that, you can just, hey, upload that frame, run an OpenGL shader on that frame, and then get the result back.
That is pretty smart.
Yeah, and also with compute shaders, you can do arbitrary operations. So like elements of graphics programming have gone out from graphics programming and into like real life situations. Even like back in the 90s, researchers would like trick the graphics card into thinking it was doing graphics, but actually it was crunching numbers for like particle simulations or medical imaging or something.
That sounds a bit funny. You think you're doing graphics? No, you're actually not. I have tricked you into doing not necessarily evil stuff, but like things you're not supposed to do.
Chaotic neutral.
Yeah.
We can say that.
Chaotic neutral.
Back when I was doing the real-time ray tracing stuff, I used images to pass in my objects, right? Because an image it's a collection of floats.
Yes.
Red, green, blue, alpha, right? So you got 4 32-bit floats per pixel. Just store your object data in the pixels.
And graphic card can do stuff for you, yeah.
Yeah.
Is it hard to debug OpenGL? I hope not.
In Mac.
I do write a lot of, yes, in Mac. It's probably going to be hell for me then.
Let me show you how easy it can be. This is RenderDoc. It documents your render. Okay, so let's say for instance we have a Python OpenGL program. What I do is I just point it to the Python executable, and then I tell it to run in this other directory where my source code is. So,
What happens if you're using a virtual environment?
That's a good question. I don't know. What I'm doing is I'm sort of running the Python executable, and then the command line argument I put is the name of the file that I'm running. And I've got this overlay saying, hey, yep, we know that you're running your program. Hit one of these buttons to capture a frame.
The frame is going up like crazy.
Oh yeah, that's just the frame number.
Oh, okay.
That's not the frame count. The frame rate is
It'll be
there.
scary.
And it says, okay, we captured that frame, and then I can close this down. And this is like, when I was learning OpenGL the first time, the thing that bothered me is there was no way to actually look in and see what the GPU was doing. But here, I've got all the operations that I did. So first I cleared off the screen, and then I basically drew all of those objects.
2048
Yep.
objects.
2048 objects. And I can go into pipeline state, and I can actually see as I'm going along what the different attributes are that I'm putting in to the program. And I can actually see, all right, well, let's go in here.
Is that one of the buffer?
Yeah, so this is the position, I believe, and I can check, okay, well, we're getting the two-dimensional positions correctly.
Yep. So where you're like having a snapshot of the buffer when you capture it.
Exactly. The point that I'm getting at is you can jump in and you can look at exactly what the GPU is seeing.
Which is awesome.
Which is awesome, unless you're on Mac and then it's a black screen. And the little error code, the number.
That is very unfortunate. But I can see everything. I'm all-knowing. As soon as I capture a screen.
Yes,
Knowledge.
so knowledge.
OpenGL is cross-platform or vendor.
Yeah, so that's why they call it open. It's because it's not meant to matter which operating system you use. It's meant to be fine for everything. In practice, it's not.
Mac OS.
Mac OS, yeah. And also, some bits in the shading language are implemented differently on different graphics cards. So I've got an AMD laptop. I can basically run anything. But then if I put it over onto my NVIDIA machine, it will throw an error because it's like you use the wrong variable name here. That's a reserved word on this graphics card, but not on this other graphics card.
Reserved word for graphics card.
Like if you use color or something as a variable name, some graphics cards will be totally fine with it. Some other graphics cards would be like, no, that's a reserve.
So OpenGL doesn't deal with that?
In OpenGL, the special variables, the reserved variables, are usually prefixed with GL, and they usually have special casing. So the choice to not allow certain variable names can come down to the driver implementation of the graphics card. Now, why they can't just relabel them, I have no idea.
Yeah.
So that's one of the things that Vulkan came in and tried to change as well. They made an intermediate language. So you can write the shader code in any shading language you want, basically, but then that gets compiled to bytecode with the intention of that bytecode being standardized. So if you say do this operation, it's meant to be independent of which graphics card runs it.
Nice. OpenGL requires an elite level of knowledge that some people will never have.
Dude, a 15-year-old kid can learn OpenGL.
That's a real story?
That's a real story. The number one thing with this channel is I'm trying to put forward that like anyone can do this stuff.
It is knowledge, but it's knowledge that people can learn.
That's right. It's pretty special. Anyone can do it, really, truly.
A little thing, actually. People think they're scary. Oh no, before starting programming, oh no, I probably wouldn't learn C. C is quite complex. No, you learn C and it doesn't take that long. One semester of paying. You think, will I actually be able to learn to make a Discord bot in 2 days? When you have no knowledge of what a Discord bot is, or decorator.
Are you drawing on real life experience?
It's real life experience. But me and my friend who found a bunch of tutorials and actually made a bot, although it's kind of it functioned, not entirely the way you wanted, but we made a Discord bot in 2 days with no prior knowledge of what Discord bot is. It's in Python, and one of our members didn't even know what class is. They haven't learned up to that point. Forced to learn class. I think the point I'm making is you can actually learn anything. There's not other people who are programmers. They're not a higher level being with higher intelligence. They just have more knowledge, and knowledge can be gained if you dedicate your time to learn them.
It's a skill. It's like a muscle. You just need to train it, and your capacity will improve as you train. Can I tell you a story?
Sure.
About my first semester where there was a third assignment, and the third assignment was just make whatever you want. And I was like, I'm going to make a renderer. I'm going to make a 3-dimensional renderer / video game. Because I came into uni for the first time and I thought, man, I'm going to push myself. I'm going to like be around people who are like more knowledgeable than me, and I'm going to whatever. I didn't know what classes were. So the way I represented the world was with a list. And it was a list. It wasn't like a list per object type. It was just a list. That's the world.
One list for the entire thing, and you just fetch things from it.
And every entry started with a code which indicated the object type. And so as you're stepping through and you're looking at the object, you see the code, you know how many elements to expect, how many elements to step ahead, and how to interpret those elements. And it worked for like arbitrary objects. So I had all this stuff. and then I didn't submit it because I was like, nah, it doesn't look that good. And I'd gotten to the point of like drawing like 3D triangles and stuff. And I was like, yeah, but it doesn't look very cool. Like, you know, I was playing Doom 3, that looks pretty cool. This doesn't look as cool as that. Anyway, so guys, don't second guess yourself. Have some fun with it. A playful sense of exploration.
By the way,
Yeah.
am I going to do the promised triangle drawing?
Are you okay with that?
I'm okay with that.
Okay. It'll be super fun.